Hey, what's up everybody? This is Brandon Dixon from Risk IQ, and today I wanted to go through a pretty interesting example of following an actor for a number of years, and one that really has exhibited some very interesting um, tactics that they've leveraged for command and control, but also just in how they go about conducting their operations in general. So for those not familiar with this blog post, this is again a Kaspersky starting point that we're going to be using here. And this is Satellite Turla. So a group that's essentially been attributed back to Russia, has other names like Eurobos, Snake. A number of different reports have come out on these guys, especially since this post here. You can see it's dated back September 9th, 2015. That'll become important in just a moment, but effectively what this blog post outlined was the use of a satellite command and control infrastructure. And what's really crazy, I'm not going to do justice kind of explaining all of the individual details here that Kaspersky has been nice enough to put out. But effectively what these guys were doing was setting up their command and control as a satellite provider. And what they were doing was essentially literally grabbing the packets out of the air. So their implant would go out, it would reach a satellite provider, that satellite provider would beam it back down to the IP address associated with that network. And the client, in some cases, was not prepared to get any of that information. And just like a TCP connection would, they essentially dropped and ignored all of that information. However, what Turla and the actors were able to do was strategically point a dish within the vicinity of the command and control server and essentially grab that information out of the air. Now, what we also observed when looking at this report, or at least how it was communicated to the industry, was we wanted to understand how the infrastructure was manifesting itself from a investigative standpoint. If you have a command and control infrastructure that's not actually establishing a connection, in other words, like they are just pulling the information out of the sky using some sort of satellite dish, then it means that the client IP address that we're going to be working with is probably not that interesting. So in this particular case, Kaspersky did a great job of identifying, some of their first seen IP addresses that they had observed, and some of the domains that were associated with these IP addresses as well. And they put together a really interesting time frame, some of it dating back as early as November 2007, at least for the IP address usage. Doesn't necessarily mean that the actor went back that early. And then other cases where it looked like we started to see an actual pattern starting around 2013 that these guys were actually leveraging this technique in the wild. So what was cool about this is that there was just so many different providers at play here. The technique was something that had never really been discussed before. It was incredibly novel. And I thought it was a really interesting case for us to sort of explore. And what we're going to do is we're actually going to start with the same indicators of compromise that we started with back in 2015. And we're going to start working our way through the investigation, noting in particular the time frames in which we observed certain data and some of the other interesting points that weren't necessarily called out in Kaspersky's original blog post. So if you're looking for the link, we'll include these just for further reading. If this is the first time you're hearing about these actors and this particular attack, I think it'll certainly be something that is very enlightening. But what we'll do for the moment is we're going to take these indicators of compromise and we're going to start feeding them into a PassiveTotal project so that we can begin our open source investigation and expanding out any other additional leads that we can identify. So I'm going to go in and I'm going to generate a new project here, and I'm going to create a private project that we're just going to call OSINT Turla. And for now, I'm going to give it a description of our Kaspersky blog post. And we're going to say Russia, Kaspersky, Turla, Snake, APT. We're going to submit that project, and then we're going to go through and start adding our artifacts here that we can then go quickly classify and start pivoting on top of. So first, here's our IP addresses, and in theory, most of these are going to be associated with a satellite provider. And these are used as command and control addresses within the system. We're going to go through and add all of these host names as well. So these were associated or seen in relation to those IP addresses, or they may have been observed in some stage 2 payloads by these malicious actors. So we're going to go in and add those. And for these, at least we'll say, stage 1. Yeah, I think that's good enough for the moment. Just so as we start to expand this out further, we don't confuse ourselves by looking at other domains that may be overlapping on those IP addresses. Okay, so I want to make sure that we have those covered. We got some MD5s here, and I'm not really worried about the signatures. Okay, so we got our domains, we got our IPs. Let's filter these out really quick. This little content bar makes it a little bit tough. MD5, oh, come on. So standard practice here, just to kind of whittle down the open source indicators that are available. So we're going to look for, put those in, MD5s. Get those all added into the project. And then we'll begin. And so essentially what I'm going to start doing here is pivoting off of all of the infrastructure that we know about and that we've classified inside of the system. So these MD5 hashes are not as interesting to me, simply because PassiveTotal and the data sets we're going to be using don't really have a great, we don't have a lot of connections associated with them. So our big focus is the IP addresses and the domains. So one of the first things that I actually want to do here is select these IPs out and make sure, let's give this a boot. I want to make sure that I tag those with a stage 1 as well, and make sure that we can go through and analyze those results. There we go. So we're going to filter these out. I want to show all 100 of them. I'm going to select that page, and I want to make sure that we're marking these as a stage 1 as well, just in case we find some other ones when we're going through our analysis process. And then, we got 33 IP addresses, 47 domains. It's quite a lot to work through here, but that's part of the job of doing the analyst work. We never know what's going to be on the other side of these IP addresses, and it's worth us doing the investigation. So again, what I'm going to do here is filter out by IPs, and we're just going to get at it. So essentially what I'm going to be looking for in these IP addresses is other related domains, any other certificates that might be associated with it, any web-based content that could be of interest to me. And we're going to go through each one of them and just try to identify any other related content that we can find here. Now, knowing that this was a satellite provider that was being used, at least from a lot of these IP addresses is outlined here, outlined right here. I think it would be important to capture these as well inside of our project, so we'll make sure that we grab those as well. So from the who is, I'm trying to think, what do we want to actually grab here? I think the organization is probably worthwhile for us to grab. So I'm going to add this into our project from the who is record. And right away for this first IP address associated with Telsat network services, we have no resolutions. We're going to skip the open source intelligence because that's what the purpose of this investigation. And we'll skip the projects too, just because we know that this is probably already associated with open source work that we've done. And we're going to focus on the unique data sets here. So we have an SSL certificate. If we think back to the time frame of when a lot of the material started to show up related to these guys and the infrastructure we saw, it's around that April 2013 or January 2013 period. We have some 2012 as well. I think to push it back to 2007 might lead us astray a bit, but we'll kind of keep an open mindset. So we're looking from at least 2012, it appears, all the way up until the day that this was published, which was around the start of September of 2015. So looking at the first IP address here, we can see we have no domains to go off of. We do have a satellite provider. And then we have an SSL certificate without much information in there. This looks like it's self-signed. It's got a common name of Ubuntu. It's got a unique serial number. And we have a time frame here of 2015 up to till 2025. So what I'd like to do is actually save that SHA-1, and I'm going to save the actual serial number as well, just because that could be unique. And what we'll do later is sort of start to explore, any connections that might be off of this SSL certificate. If I didn't want to go through the process of looking at all the individual IP addresses in order to see if other ones were using this certificate, what I could do is perform a pivot on that SSL certificate, and then I could see all of the other infrastructure we've ever seen associated with this particular SHA-1. So for the moment, we're going to shelve that information. We know that there's other IP addresses associated with it, but we want to make sure that we're working through the indicators of compromise that we identified from the blog post first, in order to make sure we don't accidentally look at something or not look at something that was connected to our original set of indicators. So I'd say here we got the certificate added, we got the provider added, and we can safely move on. So I'm going to go load up the next IP address. And we'll probably start to see a common trend here that there's not going to be a lot of infrastructure associated with these IPs. In this particular case, there is. We have some domains that are associated with the actual infrastructure. And what's nice about this is that in previous investigations, I've already went through some of this and tagged them as malicious. So what we have here is each one of these has been marked. And if you remember at the start of this video, what we did was we marked the domains that were part of that report with a stage 1 tag. And we can immediately see how that becomes useful, because I have 8 different results here, and one of them is not tagged as part of the stage 1. So because it's not tagged, I essentially know that that is something that's related to our investigation, but not something that I've already seen before. So we're going to go in here and select this norwaynews.mu.com, which just by virtue of looking at this information enough, I know is a dynamic DNS provider, as are many of these other ones. And we're going to make sure that we don't change the state because we have already marked it as malicious, but we're going to say pDNS overlap here and make sure that we're tagging that value. And then I want to go through and actually add it to my project. So this is a good example of, if we look at the time periods, it was around early September when this initial blog came out. And you can see here that following that blog is when we started to see a lot more domains associate over to the IP addresses. That was potentially a tactic by the actors, not quite clear why they did that. But in the case of this Norway News, this is a good example of why you should continually follow up on investigations. We can see here that this didn't show up until the actual next year. And so if I simply looked and enriched these indicators at the time of Kaspersky's reporting, I may have discovered some of these that showed up, in the summer period and right after the September reporting, but I might have missed this Super News Instant HQ, and I certainly would have missed the norwaynews.mu.com. And when we're thinking about analyst connections, it's very important that even one connection could be the opportunity for us to blow open a case. So I'm going to look at the who is here, and again, I'm going to just make sure that we're capturing all the different providers here from a satellite perspective. If we think back to our certificate that we just last looked at, we'll just call it F4 as a means to abbreviate it. We have the same certificate showing up on this IP address as well as the last one. So immediately I'm starting to recognize a pattern here. In Kaspersky's reporting, we're noting that the satellites were leveraged, and in theory, the actors could pull this information out of the sky as it's being beamed back down to the client. But what I think is interesting is that this SSL certificate is only associated with this IP address because at some point in time, RiskIQ or one of our partner providers did a scan of the internet, and they identified that this IP address was hosting this SSL certificate. So what's very interesting here is that we have an SSL certificate that has been essentially self-signed. It's been created by someone, not a provider. And it's showing up on 2 different IP addresses so far related to different satellite providers that were using a command and control that in theory did not actually terminate. This to me is starting to suggest that maybe there was a level of termination and that maybe the Turla actors actually had some network level access to some of these satellite providers. Otherwise, why would this SSL certificate show up? So we're going to keep going through our investigation here. We're only on 3 of 33 IP addresses. Again, you know, kind of the mundane aspect of being an analyst, but let's keep on going. So we have a case here where, again, another 2016 piece of infrastructure. And in this particular case, it hasn't been tagged at all. So we want to make sure that we're classifying it as, in this particular case, what I would do is probably mark these as suspicious because I don't quite know whether or not they're related to the actor. I will say, however, that the satellite provider, publicvm.com being another dynamic DNS provider, that this is probably related to the actors. So we'll just, for now, mark those as suspicious, and we'll say PDNS overlap. So we're going to get that tagged and classified. We'll add that over to our project, and then we're going to go and make sure we've already got this we already have this satellite provider within our project already. So you'll notice here, no certificate. So kind of a deviation from the pattern so far. Let's keep going. So I'm actually just going to mark these just because they all look similar to me. So we have no resolutions, no certificate, same satellite provider, we carry on. And that might be the case for a lot of these here. So we'll actually go and click through, let's say up to that point, up to this 209. And this is just going to be a means to, well, we'll do the last one. So we got, in theory, all these should probably be part of the same satellite provider. So nothing here on the IP address, who is information, the teleskies, and we have a new SSL certificate. So we can see here that this is a 81, so it's different than our F4, but the time period makes a lot of sense here. So I want to make sure that I actually add this to my project, and because the serial numbers could be unique, I'm going to go and make sure that we add that to the project as well. We're going to continue carrying on. So another Telesat, we have an F1 certificate. This is router.example.com. Again, same sort of time period that we're falling within. We want to make sure that we're adding these things. I would probably add the router.example.com or the Ubuntu common name, but maybe just as a means to sort of note that those were in use. But I already can tell you that they're not going to be particularly unique, and they're not going to be good analytical leads. So I'm going to refrain from adding those at the moment. So same thing, another adss.com. Looks like somebody just sort of smashed on the keyboard. We look at the time frame, it seems to line up. So let's continue taking a look, add those serial numbers. Telesat network, no resolution, so we're going to just move on. All right, so we have 2 SSL certificates here. One for this Beijing Technologies, common name of a .cn, and the other one of a common name of Mr. Green. So again, time periods seem to overlap here, and we're going to make sure that we add these into our project. And what we'll do afterwards is actually just comb through the different SSL certificates that we were able to identify and pivot on those in order to understand what could be related to our actor infrastructure. So we have those added. Telesat, we have no new information. Another SSL certificate. This is our F4, so we've already added this previously. This is what we saw with the first 2 IP addresses. So we're seeing a little bit of a theme now. We got 3 IP addresses using the same SSL cert. And then we have a number of other IP addresses that used SSL certs at varying times throughout their time period with some different information. Okay, it looks like we got a different, we still have a Telesat network services. This is a little bit different in terms of how it's being represented in the who is record. I want to make sure that we're just kind of capturing that. But in terms of resolutions and certificate information, I'm not seeing anything worthwhile. Let's continue on. So now we have another 209. This is from a similar, like the same Telesat provider. In this case, we have all stage 1 infrastructure. So again, noted by the case where we've already tagged that information when we did our initial onboarding inside of the project. And again, we have an SSL certificate, looks like a new one. And this one might actually be related to the satellite provider itself in some form. So we're seeing bel.vsat. So issuers out of Ireland, same sort of process here. It meets the time frame in terms of the actor. So we're going to go through and add those into our project. We don't know if they're necessarily great leads yet, but they're certainly worth exploring. Okay, stage 1 already tagged. Just check the provider, same Telesat. I think we can move on. All right, so very quickly we just cleared through a number of those indicators, and let's start going through all the 217s. Try to load up as many of these as we can just to kind of accelerate this process. So we'll stop at the 82s. So we'll let all these load up, and we'll start taking again a look at the output here. So all stage 1 indicators so far. We got a different provider here. It looks like Sky Vision is the ones that are being leveraged for this IP address, at least at that time. So let's make sure that we grab this unique looking organization name. It doesn't appear to have changed. The network itself, though, is ASNs on the Sky Vision. So it might be worth just adding those ASNs in to our project later on. We can go through the Kaspersky reporting if we really want to. So separate satellite provider, same F4 SSL certificate, worth noting here. So that's now just kind of keeping track in our head, 4 different IP addresses from 2 different providers using the same one SSL certificate that was created by someone, self-signed. Let's keep going here. Untagged infrastructure, I love it. So no certificate in this case, but a slightly more active set of infrastructure here. And you can actually see that some of this goes out to May of 2018 that we've noticed these domains associating with this previously used satellite IP address. Now, I'm interested in this simply because what I'm seeing here with linkpc.net, publicvm.com is that I know that those are dynamic DNS providers, and I know that that sort of meets the kind of modus operandi of what these guys are doing. And so maybe these things, maybe despite some of that public reporting, it looks like the actors didn't necessarily stop associating their dynamic DNS infrastructure to a lot of the satellite IP addresses. Does that mean that they're still being used? Not necessarily. These could be something that maybe a security provider like Kaspersky has gotten a hold of, and they've been able to sort of take control of these things. Maybe these domains just happen to be something that somebody else used that has nothing related to these malicious actors, and it just happened to be a coincidence that someone set up a new dynamic DNS provider or a dynamic DNS address and happened to point to the same satellite IP address. Who knows what the example is or what the cause is in this case, but I think that these are certainly suspect. We can start to look at the domain themes after we go through these IP addresses. But for now, I want to certainly mark those as suspicious with a PDNS overlap. And I want to get those added into our project so that we can go and track those later. We have a new organization network where we're going to put the name in this case is a little bit more descriptive. We'll put them both actually. So we get that VSAT network. So another provider but no SSL certificates. But now what we're seeing here is it doesn't appear to be any necessarily rhyme or reason behind the use of domains pointing to these IPs either. You know, we're seeing domains here, but we're not seeing an SSL certificate. So kind of different patterns emerging. If we keep going through, let's see, Sky Power organization, so another unique one here that we want to grab. No SSL certificate, no resolution, so we're going to keep going on. Okay, so got stage 1, so already known to us, and then from an organization, looks like we have OrionCom as another provider here. Make sure that we add that one in. and no SSL certificate. Let's keep going through. So we do have a 2012 address here. I don't know if rr.nu has anything to do with these guys, but it's worth adding it in as suspicious simply because we know 2012 was a rough idea of when this could, when these actors could have been in play. So PDNS overlap, mark it as suspicious, add to the project. From a whois standpoint, we had another Denmark organization. So I mean, you know, I'm thinking about these guys already. The technique is already really interesting. The fact that they're using satellite providers, but what's intriguing here is the amount of satellite providers that these guys were using. And I guess that would make sense if, in theory, you never had to terminate the client connection with your implant, then you could just indiscriminately grab at satellite providers. Well, actually, maybe I guess you couldn't because you would have to have range. So all of the providers would be interesting. I think Kaspersky did a little bit of analysis around this, but they would, in theory, have to have some sort of geo presence or like be close enough in physical proximity to where the information would be beamed down in order for them to essentially collect that information out of a receiving satellite dish, or even to probably connect to it. You know, I'm not completely certain how satellites work. I don't want to kind of misstep, but I wonder if you actually have to be within a certain range to actually make a connection to a certain satellite provider in order to obtain a certain network address. In either case, we carry on. So we got no resolutions, no certificate, but yet another organization here, Denmark, but the whois information itself is slightly different, so we'll capture that. No resolutions, but we have a certificate, and I believe we saw this one before, so potential pattern here, a little bit of overlap. I'll add it just in case it wasn't previously added to the project. Oh, we get a little notification here already letting us know that it exists. Keep going on. Satellite provider. So this is what I would probably expect to see a little bit more of on a satellite provider IP address, this lbcgroup.tv. I don't know too much about it. I also don't know if satellites can kind of share the same IP addresses as well. We note some time periods here. The dnscheckup.biz, not quite sure if that is a dynamic DNS provider, but I do know that sites.net is. So we're going to go and just grab all of these because who knows, they could all be related. Suspicious, PDNS, overlap. Submit, add to project, make sure that we got those covered. Look at the ASN up top here, Lux Green Technologies, probably some different provider. Organization-wise, let's just make sure that we've added that in. I'm not quite certain if we have. All right, looks like it's new. Let's keep going. So epac.2, mefound.com, zzux.com, all of these are dynamic DNS. And look, we have heat map action, which is showing that in the past 6 months, we've actually had material as well. So pretty interesting. Lux Green Technologies, not quite certain how they are in terms of a satellite provider, if that is their primary function, but 2018, April 30th, we first observed this dynamic DNS domain pointing over to this, this IP address, and it goes to show that these guys still could be active. So we want to make sure, again, capturing and categorizing. Overlap. Let's get these added to our project. Let's grab that. We already added that last time, but we do have an SSL certificate. If you think back from the first time, this is now the 5th time that we've seen this F4 certificate show up, now across 3 providers. I think we can safely move on here. We got OCRI, another dynamic DNS provider, stage 1 already accounted for. Whois information is telling us this is Satellite Media Port. Completely different organization name, we'll add that in. And then another same SSL certificate being used here. So now 5 providers. So 77s are done. Let's rip through the 80s. Mark off at that 92, and look, we're almost done. Now I have the fortunate background of understanding, you know, like the beauty of open source intelligence, especially after years has passed, is that there's a lot more data that associates to the infrastructure. And if the actors are still active, then it's a great opportunity for us to sort of continue to follow on what they're doing. At the same time, it can be very complicated because all of these things that are not labeled could be security researchers who have decided to register these things and complicate the process. It could be sinkhole efforts. We're not exactly sure whether or not this is related to our, Turla Russia actors here. But right away, 82, we got our Lux Screen Technologies. I can see immediately we have 2 domains here that have not been classified. We're going to do that, PDNS overlap. Let's take a look at the actual Link PC and public VM, both dynamic DNS providers. So it continues to follow the same pattern. Here's our 81 certificate that we've already accounted for previously. So similar to that F4 certificate, it looks like this 81 is becoming a good source of overlap and correlating points as well. Let's keep going through here. Whole lot of nothing on this one, so absolutely no value. No real value on this one either. Capture that organization because I don't think I've seen it before. Okay, that was new. All right, 14, a lot of stage 1s, but 2 others here that we've got marked. Let's go through PDNS overlap, get these added, and both of those are dynamic DNS as well. Sky Vision, so different organization here. Let's go grab that. And then certificate wise, we have this FCC certificate that was issued much later. So we're going to capture this, grab that serial number, and we see our same F4 certificate that we had previously attributed on those other IP addresses. So one of the more unique opportunities here, we got an SSL certificate that we know was associated with multiple satellite providers and the time period of Kaspersky's reporting. And then we have an SSL certificate that seems to follow a similar self-signed pattern that is showing up a couple months later after the reporting. So it could be indicative of the actor changing the SSL certificate or adjusting it in some form. But let's keep going. So this is what I would expect to see from a satellite provider. These sort of reverse looking IP address hosts. Not too much value in terms of just the, we got a satellite provider appears to be based out of Germany. We have a German domain here. Seems to be associated with like some customer, in the name itself. I'm going to venture to say this is probably a good domain and just a reverse lookup that showed up here. So I'm not going to add that in. I do want to add the organization into our project, but we'll note here that there's no SSL certificate. So we're in the final stretch of the IPs. Let's get all these 90s loaded up, and then we can sort of reflect on what we got. So new organization, add that in. No SSL cert, no resolutions. So we got our serve to RR. We got some other stuff showing up here. I don't know if eForum is something that is a dynamic DNS provider. If I wanted to, I could do an inspection on that. But what I do want to do is mark it as suspicious just because it does fall within the same time period. And it could be done. Get those added. Who is gives us, I think, another organization. Okay. Man, going through IP addresses like this makes you sleepy. This is kind of the boring work of analysts, just covering all your bases. So we got those added, no SSL certs. Let's keep going. All right. So this one we have a lot more information associated with stage 1 here. So we don't want to add those in. So let's make sure that we go out. Got a couple other 2016 showing up. 4DQ, Got Game. Those are probably dynamic DNS providers, or I think that they might be. They at least match a pattern that we saw similar in other infrastructure that was used. So let's mark them as suspicious, PDNS overlap, submit those, add to project. We do have another organization. I don't even know what that means, but we can see in the ASN, same satellite provider. And from the cert side, we got that same 82 showing up. This time it's that Beijing Technologies one. So it's been a little bit since we've seen that. Okay, so we got those accounted for. Let's keep going. Nothing here except for an organization on Skylinks. So ASN says satellite media port. No certificate, no resolutions for us to look at. Final IP address, we got stage 1 already accounted for on the passive DNS, and whois gives us yet another unique looking organization name. And again, these are probably not something I would pivot on, just because we know that the satellite providers are probably going to have some level of relation in how they use the names. But okay, let's take stock of what we got here. Stage 1 IP addresses used by different used as command and controls across multiple different satellite providers. We got those accounted for. I'm going to go and uncheck that. I want to check all of our domains here, and I want to show all 100 of them. And I want to make sure that I'm looking at anything that's tagged as stage 1, which in this case will be everything, only because I haven't refreshed the screen yet. And what I want to do here is, you'll notice that some of these have not been classified as malicious. I want to go through and do that right now, just so in the future, as I'm pivoting around, that color coordination can give me an indication of whether or not I've looked at it already. So I'm going to modify all artifacts. I'm going to just tag them as malicious. And what that's going to do is essentially persist that tag within the database and make it easier for me to identify cases where, 1, the red is what I've already seen, and 2, the yellow is anything that I added with that PDNS overlap tag. So at this point, as an analyst, I got a couple interesting cases here. Let's kind of deselect everything for the moment and take stock of what we had. We started with around 50 indicators, I believe, and we've already kind of ballooned this out very quickly just by looking at the IP addresses that were used for command and control, which in theory would typically not provide us with too much information. So I have 8 different unique serial numbers and SHA-1 certificates that appear to be self-signed in nature associated with this infrastructure. So I think what I'm going to do first is go through the domains that we had, and specifically the stage 1 domains. And what I want to do here is run a pivot on each one of these and identify if there's any passive DNS IP addresses that we can sort of re-add into our database. So let's begin doing that. We got 47 of these. This is going to take a bit of time, but that's the whole purpose of doing this. And actually, before we start going through and doing that, I want to just take a quick look at all of the different results that we have here and take stock of what we're looking at. Strangled.net, sites.net, Chicken Killer, Public VM, Crab Dance, Moo. For a lot of people who may be new as analysts, like, these domains look really crazy, especially ones like chickenkiller.com, but these are dynamic DNS providers, and what those dynamic DNS providers do is they essentially buy domains like hop2.org or ignorelist.com, and they make the subdomain portion of those available to anyone who wants to get a domain. And so the idea is that if I don't want to purchase a domain, I can go to a dynamic DNS provider like this one, and like ignorelist.com, and I can choose a unique subdomain, in this case wargame, and have that become my domain. They allow me to control the DNS aspects of it, to point it over at different IP addresses, and in a way it's like having a domain that I didn't have to purchase on somebody else's infrastructure. I don't have to maintain it either. But from a malicious actor perspective, we see these providers used often simply because they're a third-party resource. That means that they're not having to be maintained by the actor. They have some level of like deniability in that, hey, that's not our infrastructure. We didn't set that up. And it's an obfuscation point from an analyst perspective, because the actors could have bookstore.strangled.net and then choose to get rid of that, and somebody else could come along and say, hey, I want to use the bookstore subdomain, and then point it to separate infrastructure that has nothing to do with our original attacker. So worthwhile in exploring dynamic DNS domains. It's also worthwhile in noting which ones are dynamic DNS and which ones aren't. The ones that aren't means that they've been directly registered and could, in theory, have some whois information that might provide some value. Cursory look at what I'm seeing here, the 47 domains, all associated with Kaspersky's reporting, is that we're primarily dealing with all dynamic DNS, and therefore whois information is not going to be valuable to us. So I'm going to take a quick break before we start going through these domains, and then we'll start exploring the passive DNS and anything that we have related to those. Okay, let's start going through each one of these domains here and identifying what we have from a passive DNS perspective, or any other data sets for that matter. Because these are dynamic DNS, we're actually going to be ignoring the subdomains tab simply because that's not going to provide value. Also, because it's dynamic DNS, we're going to avoid the whois tab as well. Anything else is fair game though. So what we have here on our first pivot is some IP addresses, and all of these match time frames. So what I'm going to do is make these marked as suspicious, just a standard habit that I have of marking IPs as suspicious, simply because they typically change hands, especially with something like a dynamic DNS address. I'm going to again put our passive DNS overlap tag here and make sure that these IPs are now being added into our project as well. So same concept that we had when it came to the IPs of adding domains. When we're exploring domains, we want to add in related IP addresses, so then we can do a stage 2 analysis where we pivot off of all of those. So we're just going to keep working our way down here one by one. So bookstore.strangled.net, another same provider, and a couple other IP addresses. We're going to grab these. Only one of them has been marked as our stage 1. And you can see here that these have appeared to remain active. And so it doesn't necessarily indicate that they're related to the malicious actor. However, there is that connection, and we have to go through and interrogate each of those results to identify if it does appear to share some of the same characteristics. What could help us, at least kind of looking initially, is to kind of understand the ASNs. So I'm seeing here at least that the first one that we knew was Telsat. We also have Intersat, SkyLogic, Network of World, I don't know what that one is, Emerging Market Communications. So all of these so far at least seem to point and suggest that it could be a continuation of the attack despite the public reporting. So let's keep going through. And I think that's particularly interesting, that despite the method being compromised in a way, these guys have not necessarily stopped their operations, or may not have stopped. So we already have these tagged as suspicious, but I want to make sure that we got that PDNS overlap and that we've added them to our project. Not seeing any other data here. Oh man, this one, you know, you've been doing it. Completely forgot the one that I was looking at. So we'll go through the same approach that we had before. We're gonna just go through the C's and then the D's, just as a means to sort of keep us organized a bit. Zapto.org, another dynamic DNS provider. We got 2 IPs, ASN, UCOM, and starman.as. I don't know if those are SAT providers, but we're gonna mark them, because at least to this day, this cars-online.zapto appears to have valid information, or valid resolution history, as indicated by our last 6-month window here. No certificates, subs, and whois are not going to be valuable, so we carry on. PDNS overlap. All right, so we already got these accounted for, which is nice. And I'll make sure that that is marked appropriately. Okay, so let's keep going on. I think that was the same one we were just looking at. So C's are done. Let's go through and do D now. So moo.com, another dynamic DNS provider. Resolution history, let's see what we got. Nothing new here. So again, this is the value of grooming that information as we go along in our investigation. You can tell by the tag, this is stage 1, which means that this was the original infrastructure that was identified by Kaspersky. And then the passive DNS overlap is just the stuff that we're doing right now. So as we feed this in, this makes the process go much faster. I don't have to spend time interrogating whether or not I've looked at these IP addresses already. So I'm going to close out that, and we have the same results here. Again, no new information. Let's close it. So D is done. We'll go through E's now. Okay, new IP address. We can tell right away. It's 2014 time period. What's the address? DigitalOcean. So this may not be that interesting. Could be a sinkhole. Who knows? Doesn't appear to be a set provider that we know of. We'll store it nonetheless. And we have a new tab here for DNS as well that happened in so netdorm.com DNS exit. So it's using different name servers than the DigitalOcean ones. So that could be of interest. Just for analyst's sake, let's run a quick pivot on here. Identify what else is going on related. Actually, you know what I want to do? I don't want the SOA. Let's run the who is. Okay, so in terms of data itself, when thinking about like name servers, this one's pretty interesting because there's not a lot of results that are associating to it. And of the results that are, there's a publicvm.com, a link PC. So I wonder if this DNSexit.com is somehow a preferred provider for these actors. I think what I'm going to do, just because I don't want to spend too much time digging into something that may not be worthwhile, is I'm going to add these name servers into our project, just because there's not a lot of information there. And if these guys have set up their own name servers, then it allows us to potentially correlate their infrastructure together in another way. So we'll move on. PDNS overlap, nothing there. We do have this. This is interesting. So got some trackers here that are related to Eurovision.chickenkiller.com. And the values that we're seeing are Google Plus IDs, Facebook, LinkedIn, YouTube, Twitter, and Optimizely. So these are definitely of interest to us. Looks like they showed up in 2018. And what it's telling me, or what I'm getting out of this, is that our RiskIQ web crawlers crawled Eurovision.chickenkiller.com on January 3rd. And in doing so, had observed a web page there, or some sort of web application that at least made reference to cars.com in a number of different ways. If I look at the components here as well, we start to see things like ad networks and advertising stuff, tracking pixels. Pretty interesting. I wouldn't expect to see this on a dynamic DNS host. But it's not completely natural. Got a bunch of images here from the C static graphics, ClickTel, Mantic.com. I don't know what any of these are, but I do know this. We got cookies too. So CASalemedia.com. So this looks like a bunch of ad providers. Rubicon Project. You know, maybe this is a case where the dynamic DNS domain was essentially taken over by someone else, and they've chosen to put a legitimate application on top of the server itself. And because it's so far away from the original reporting from Kaspersky, it would make sense that there was a change of ownership. What I'd like to do here is just flag this particular domain as an interesting one, simply because we're seeing those results. We probably want to go back and try to explain why that's happening. and look to see if we can correlate any other activity here. So let's just put, I don't know, web app. So web app will just give us some sort of indicator that lets us know that it appears that at least there was a web app running on that domain. Okay, let's keep going. We did E's, we're on to the F's. Stage 1, we got a component here, so it looks like it's running some sort of Hala server. I don't know what that is. Let's run a quick pivot on it. See how many other results show up related to this. 2,300. Probably not going to spend too much time looking at it, just because I'm seeing Twitter show up in here as well. Could be a popular technology that's used. I don't want to look at this too much, but no other real information here that's new. IP address is part of our stage 1. DNS gives us change IP, which we would expect. This is interesting though. So at some point it looks like they use their own MX record for this resolution. Is there anything else? Oh, we already have those results. I want to add that in just because the provider that they're using could automatically set up an MX provider, but maybe they actually went and deliberately did it. And this 25 FIFA-rules.25u.com, maybe that's something that they were actually receiving mail on. And we could see here that it was earlier today that we observed that this mail exchange record had shown up, so something very recent as well. Let's keep going. Okay, this is a great example of why we categorize our infrastructure as we're looking at it. We could see here we got a time period that dates back, keeping in mind our original reporting said maybe 2007 for some of the IP address associations. In earnest began kind of in 2012. So we can see here that we got a bunch of different providers. I'm going to skip out on these. I'll take this. Let's look. EDS, Satellite, Lux Green, GigNet, Starman, JSCC, UCOM. So we already got some of these accounted for. I want to make sure that we get all of them that kind of fall within that time period brought into our project, and that they're tagged. So we're going to make sure that these are suspicious, PDNS overlap. Now at this point, probably would have made a little bit of sense to actually go through and tag the IP addresses that we knew were satellite providers, because as we come across more of them, we may not necessarily know which is which, and it could be confusing. In this particular case, I don't know if some of these are satellite providers or not, which can make it a little bit harder for me to process this data right away. But we got that information added, we got F done, let's continue going down. We're on G, we got 2 results there. So OCRY and strangled, and value of our overlap, of our categorization process, this is already done, no new information, we close it out. We got some old information here, so, let's look at these. Multinet, Moscanet, Skyvision, Satellite Media Port, Emerging Markets, Skyvision, Confluence, Emerging Markets. So I'm going to say that we know the emerging markets are definitely worthwhile. Confluence networks, I'm right away on this, looking at that going, probably not related. What do I want to do though? Do I want to keep them? No. Let's kind of short circuit this process really quick. I'm going to run a pivot on them. I'm going to see what results show up. In the meantime, while that loads, I do have something that falls within the time periods here that are not tagged. And so I want to make sure I note those for further exploration. We'll put them as suspicious right now. PDNS overlap. We're going to save these, add them to our project. Let's see if that 209 came back. Okay, so 4,000 some domains. I'm looking at this. This to me looks like a hosting provider. The reason why I believe that is because if I look at the past 6 months of history, I can see these orange flags associated with each day. And that gives me an indication that some new event had occurred that day. I'm venturing to say, I know Confluence Network is more of a hosting provider. The indication that I'm seeing here with the heat map is the same sort of history. I might as well look at the certificates and see if there's anything that sticks out here. But I'm seeing cPanel, some random looking domains. I'm not going to add these in. I'm making my game day decision. I'm going to continue moving on because I don't think that those are actually related. And I would be a bad analyst if I didn't go and look at the other one. So as much as I don't want to, I would need to make sure that I'm not practicing bad ways of doing analyst work. Let's actually go and look at this and see if there's anything here. So only one IP address up. We already know it's part of the same ASN, same net block. Right away, looks hosting to me. It even has some of the same domains that we just saw previously. Again, I'm gonna close this one out. But actually, before I do so, let's look at those certs. Make sure it doesn't bite us later on. So a lot of 2018 certs. Not a lot of stuff that I would put as particularly interesting here. Closing that out. All right, so we're not going to add those in. We already added the other stuff. And so that was G. Let's move on to H. I think what's interesting here is just the amount of unique letters that have been leveraged by these guys. It's almost like 2 to 3 examples for every letter. So we're already clean here. We do have some new DNS on this fax serve. Change IP. And we got the MX record. Let's make sure we grab that. Load that into our project, continue on. All right. So we have some satellite providers here, Intersat, Telstra Global, ARPCE, Skyvision, Gilsatcom, emerging markets. All of these are fair game. And they're all recent. So suspicious, PDNS overlap. So if you've noticed by now, we're going to end up with a lot of secondary IP addresses that we need to explore from a passive DNS perspective. And the reason why we want to explore those is because they might potentially have other dynamic DNS domains on top of them that could be related to these actors as well. All right, so we have these categorized. There's no other new information. I think we can move on. Both of these are accounted for. No new data. Let's keep going. So we're on to I. So we have just one in this case. Let's load up L and M at the same time so that we can just sort of speed along here. So how many do we have left? Pretty good amount. So we're about halfway through. Already getting a lot of good leads here with the satellite providers. No new data. Keep going. No new data here. Some DNS. No IP. So that's the dynamic DNS provider in this case for servequake.com. More IPs here. So let's look at timeframes. 2011 meets what we want. Level 3, Amazon, Giganet, Gig Prime. I'm hesitant to say these L3s are probably not going to be interesting. Up top here, it kind of matches our PDNS overlap from before. Let's make sure we include it. Let's go pivot over really quick to these L3 addresses. If I really wanted to save myself some time, I would just add them in, but in some cases I don't feel like complicating the project more. Seeing that, at least from a historic perspective, a lot of those IP addresses did not necessarily appear in the United States. And seeing US comes up makes me inclined to believe that they may not necessarily be related. And that's why I'm just going through this process really quick. So less hosts on a regular basis. We do have some no IP stuff here. Smalltalk.bt. So the fact that I'm seeing other like Zapto, Hop2, no IP, I'm more interested in this. Maybe these are related. Just because like Google.com.hop2, those sort of stick out to me. So I'm actually going to, I'm going to go against my initial judgment. And we're going to mark these as suspicious. They technically fall within the time frame. And it looks like there's some other DYNE related to it. We're pointing off of it. So we'll add the tags in there. We've added those to the project. Give it a second for that to take. All right, Russian address 2015, Neoprint LTD. Doesn't feel like a SAP, but we're going to put it in. So we've got some DNS here that we want to take a look at. DNS exit, so those guys show up again. We already got those accounted for, and you know what, I'm going to pivot on this netdorm.com because I didn't do that previously, but it could be something that's related as well. It looks like a little data snafu on our end that we want to ignore. But it could just be that this SOA record address has not been indexed in our Whois database. So it looks like this was showing up uniquely from an SOA perspective, wasn't in Whois data. I'm going to add that in there. And we'll continue moving on. Nothing new. We're ignoring hashes for the moment. Let's keep going. All right, we've made it to N. Okay, new dash book. So at this IP, what's the provider? DigitalOcean, probably not related here. PDNS overlap. Could be a sinkhole. Got some DNS. We got our DNS exit there. So that showed up like 3 times now. I wonder if that DNS exit is maybe associated with some sort of sinkhole provider, and that DigitalOcean, a common way of spinning up hosts very quickly, sometimes favored by sinkhole folks. Maybe that's what's going on here, is that someone's registered a sinkhole, they've decided to take control of some of these dynamic DNS domains, they've set up their own DNS, and what they're doing here is just correlating some of this infrastructure so that in the event that the people are still compromised and we're seeing these domains leveraged in some implant, in theory, when they go to communicate, it'll go right over to the sinkhole that's ran by the security researcher. Maybe they'll get some additional information. That is going to be my going theory at the moment. Okay, so most of this is already accounted for, except for this Great Britain address. Let's get that covered in. And here's another example of a domain that appears to have trackers. Same ones too. So we noted before that there was a web app running on that chicken killer one, and now we're seeing a web app here. And it would be less suspicious if it were not the same information, but it appears to be related to cars.com. And if we look at the components that are running here, we see some tracking pixel. Actually, this is interesting. What's this? Any useful aspects here? No. See that same sort of like media before. We have some Optimizely stuff, which we know was in the tracker, static images, all things that seem to indicate some sort of web app running, cookies that go along with it. So two different domains associated with satellite providers as part of dynamic DNS providers on 2 different ones have been seen now associating some web application content on top of them. A little strange, you know, from an analyst perspective. Certainly looking forward to exploring that component once we get there. I'm going to refresh this just because I can't remember if I literally added that IP address in. I did. Doesn't look like our tag took place though, so make sure we get that covered. And just to be safe, I want to add it in there and tell the application will let me know if it's already been added. So there's a slight little delay here. So okay, that was not added. So I went through part of that process and then got distracted. So the reason why we kind of double check our stuff here. PDNS overlap, nothing new. Same. And same. Oh, but look, got a web app, cars.com running on this one. Let's mark that. Okay. So we got N's done. Let's switch over to O's. Do P and R at the same time. And we're getting to the bottom here. Okay, so O, suspicious. What we got? Gilsat, emerging markets, Confluence, Confluence. So before we didn't have those Confluence networks, I recognize those IPs. We've seen them before. I'm not going to add them again. Suspicious, PDNS overlap. Save. Add to project. We got one component. Let's guess. Hulla? Oh, Apache. So always worth taking a look at those. Doesn't look like we're seeing any web app here. We do have a cookie though. That's interesting. Sellclassics.com. So they dropped this cookie at some point in time. VSID. I don't know what that stands for, but I'm interested in any other place where that cookie may have shown up. Nope. What about the name? The name doesn't look unique at all. So this is either gonna bomb out, we're gonna get a lot of data, and we're getting a lot of data. So 1,127,000 results. I'm not even gonna bother. Let's move on. Stage 1, new data, DNS, change IP. Got our MX record there. Let's add it in. Nothing else that is of interest. Olympic is interesting to me just because we're starting to see maybe like a little bit of a theme. Press forum. So we got two IPs here that haven't been accounted for, fall within the time period, Prime SA and Forthnet. They don't seem to match, but I'm gonna put them in because they have that time period. All right, submit that, add to project, OSINT Turla. So maybe some sort of news theme, technology theme, press theme. Got all these accounted for already, so we can move on. And we're into the S's. A lot more of these than we have seen in the other ones. So news and sports theme is kind of interesting here. Oh, I started going into the T's. We'll kind of mark ourselves there. So clan.publicvm, no data, carry on. Secure source, no new data, carry on. SoftStream, nothing new. Sport Academy. Web app. So we got another cars.com showing up here. Just a couple different providers showing up with that web app tag. I'm not going to go bother through looking at this really quick or right now, just because I know there's enough of a overlap here that I want to really go and explore those more. So I'm going to close that out. Sport newspaper. So we're getting like news and sports showing up here. Things related to the Olympics as well. You know, it certainly falls in the interest of Russia, especially if we think about the doping scandals that took place. So no new data here. No new data. Got our web app again on Super News, Instant HQ. Let's go and mark that. Resolutions have already been accounted for. No new data. None. Some DNS information here, but everything else is accounted for. Tiger Got game. We'll add these in. I don't really think they're probably going to be that useful, but just the fact that it has an MX record could be helpful in the future. There's a reason why the other ones don't have it. Maybe it's the provider that they chose that didn't bother to set it up. All right, so we started to go through T's. Let's finish these out. Look, we're almost done. Okay. So top-facts, another interesting choice of domains here. Another IP, Japan-based, UCOM, falls in line with what we were used to seeing. Let's make sure that we get a PDNS overlap. And if you've noticed so far, in exploring all of these domains, we have yet to see an SSL certificate that's been issued for any one of them, which I find to be kind of interesting, but it sort of makes sense. I'm not sure you could get an SSL certificate for a dynamic DNS provider. I think that you could. At the very least, you could at least generate a self-signed certificate like we saw before, but so far I've yet to see that. All right, so we're all accounted for here. No new information except for this name server. And this name server looks kind of unique. Let's pivot on that. So maybe not indexed. We'll add it just in case. At least falls in the early time period. I don't know if that's necessarily something we want to focus on too much, but it's worth adding. Okay. No new data. Nothing. All right, we got two new IP addresses here. One, the Netherlands, back in 2011, and that's a Signet, and then a UCOM. So that might be the same UCOM that we've already added, but just in case, never hurts to kind of do some of this stuff twice. So add those into the project. We don't have a web app in this case, so we don't have to worry about those. Got that accounted for. No new data. DNS, change IP. And our final one, no new resolutions. We do have some components, CentOS, OpenSSL. Not that interesting. I'm willing to move on. Okay, so let's take stock of what we got here. Went through all of the domains that were associated with stage 1, and keeping in mind we started with 50 indicators of compromise, and we've now ended our first pass of IPs and domains, and we're showing up with 200 some indicators of compromise. That's a lot of information. So what I want to do here is just kind of filter down all of our domains and make sure that everything sort of got tagged appropriately. I want to make sure that we're looking at the PDNS overlap. So we could see here that this one and this one were tagged, or not tagged, but marked inappropriately. So we want to mark those as suspicious, just to make sure that we're on the same page. So we have 25 new domains associated with these guys. What about the web app? So these are the really interesting ones. So Eurovision, New Game, Night Street, all of these are different primary domains, which when it comes to a dynamic DNS provider, they may offer multiple different primary domains. So these all could be part of the same provider, though I'm not quite sure if that's the case. If we just go to chickenkiller.com, so it's a free DNS. Let's look here. Can I find out what domains they have? Oh, it doesn't look like it. I might actually have to register. So afraid.org is the primary provider here. And it looks like I might need to register in order to see the domains that they have available. But at the very least, from an analytical perspective, what did we end up with by going through all of those domains? Well, we ended up with more IP addresses, a lot more. We ended up with no more SSL certificates, but we did end up with that curious case of the web application showing up. So what we're going to do is take a quick break, and then we're going to start exploring the SSL certificates in order to identify any IP addresses that we're seeing hosting those, and then we're going to follow up with the web applications. So we'll be back after a moment. Okay, so from an investigative standpoint, what we've done is what I would typically call a stage 1 pass. So we've looked at all of the immediate connections to the IP addresses and domains that were originally called out by Kaspersky, our reporter in this case. And what we've done is went through and just tagged everything accordingly. I just noticed that as I was scrolling through these results, this one's missing a tag. And so what I would like to do here is just quickly identify anything that does not have that. We'll get rid of those. So it looks like these two missed our tag for some reason. So we want to just assume that they're PDNS overlap. maybe they didn't get applied, and get those in there. So we perform our stage 1 pass. At this point, we've identified, in my opinion, 2 key details here. One, there's some web applications running on a couple of the dynamic DNS domains. And 2, there was a number of self-signed SSL certificates that appear to be associated with a number of IPs. So both of those are, fortunately for us, low in number, which means it should be pretty easy to get through this information. So we have 8 SSL certificates that we need to go off of and start exploring. So let's go through each one of these and see what we can find. So what I'm going to do here is note just a couple details. 1, self-signed certificate. 2, this particular view is a pivot on that SHA-1. So in order for an SSL certificate to be served up to someone who's visiting a website, it needs to be associated with a host in some form. And so what this view is showing us is that this SSL certificate was first observed back in 2013, October 30th, and these were all of the different IP addresses that we had observed this unique SHA-1 certificate showing up on. So the view doesn't really lend itself well to kind of re-importing this information, so I'm actually going to cheat a little bit. I'm going to go through and highlight this infrastructure, and I'm going to go back to our project. And I'm actually just gonna, I wanna make sure that I wanna copy this because I don't wanna mess up our ability to pivot, but I wanna make sure we're ingesting this information in a good way. So I've highlighted the IP addresses. I'm gonna add those as artifacts. So keeping in mind that they may already exist. And then I want to put just SSL overlap as a tag here. And let's see what happens when we do that, because in theory those should already existed. Hopefully we're not rewriting or overwriting some of our existing tags here. So actually it looks like based on the count we may have ended up with a little bit more artifacts. So let's see if that's truly the case. And we can filter it out. Okay, so these actually, it's claiming that we haven't seen these before. So, not quite sure what to make of that. Do I believe it? I'm just going to refresh just in case. I was get a little skeptical of these sorts of things, just because I would expect those IPs to have maybe shown up, especially since we added them from one of the SSL certificates. Oops. So I want to do this one. Oh, I wonder if it reclassified them as well. Let's go back to our original reporting. Unsuspend this tab. So maybe these are brand new. Okay. So now curious, let's run a quick pivot on one of those. No data, but there is one of the certs. There's our cert. Okay, so in this particular case, these IPs may not have shown up before, simply because there was maybe multiple certificates on the infrastructure. It's kind of strange to me why there's that's not necessarily showing up here. And I just want to be completely sure of what we're looking at here. Okay. Sometimes weird things occur like this. So, okay, we got our first certificate out of the way that we've added in, and it's got this unique infrastructure we hadn't seen before. So I want to actually bring back up that project page because we're going to use that as we pivot through other SSL certificates as well. So I actually want to go a step further here and take that SHA-1 and update the SSL overlap with it, so we can sort of preserve where some of these IP addresses came from. So we'll add that in as a tag. So we'll do SSL-overlap, and then we'll also put in the SHA-1 of the original source. So I think we can close that one out. We're going to go do this 81 address. And we have a small set of IP addresses here. Again, similar 2013 time period. Another looking self-signed one. Let's go and add artifacts, IP, SSL overlap, And then again, we want to save off that information. And that is something that I like to do just because it helps to give me context, especially as there starts to be overlap between varying IP addresses or certificates. If I can preserve that in the project in some form, it helps me get the work done, or helps me organize. So let's just make sure. Okay, cool. So we got 13 of those. Let's keep going. So 82. Add these in. IP. So at this point, we're not actually doing any real analysis. We're kind of just doing the background information needed to capture the relationships that exist between the infrastructure. And we'll kind of look at what shows up afterwards and then start to assess it from there. Okay. Pivot on this 9D. So we only have one in this particular case, this 209 infrastructure. So I'm going to make sure we collect that. I don't know if there's necessarily SSL overlap in this case, but we'll keep it organized just in case. Keep going down. Actually, we'll let this load just in case. Okay. So far, a pretty average amount of IP addresses hosting the same SSL cert. Not that suspicious, personally, looking at it. You know, a self-signed version of this, or in this case, like some random looking cert. I would expect maybe 3 addresses to be used over a period of time. It could make sense. We'll have to figure out some context as we go along. I want to identify cases where there might be more infrastructure associated with one of these. That could be indicative that it's hopping around a lot more, but so far this looks like a fairly normal pattern. I think our first certificate had a little bit more, but you can see here a couple of these just have like 1 address associated with them. So I wonder, was that the same 209 that we saw before? Okay, this was part of our stage 1, which makes a lot of sense. Let's go through and just see what happens when we re-add that and say SSL overlap, and then capture this. Does it actually merge those tags in, or are we overwriting some of our work here? Because if we're overwriting some of the work, we want to at least know that. It's not necessarily a bad thing. You know, from my perspective, I would imagine that it could overwrite it, but I'm hoping that it merges. All right, so IP address. Oh, we want the 209. Which one was that? 35. Actually go through and just, so many of these addresses look the same, it's hard to tell. Oh, we need to expand our notes again. Okay, so it's actually quite the opposite. It does not re-add it to the project. So let's go back through. Well, in this case, we're not losing too much other than the fact that we're not getting the intersection between the existing infrastructure and the non-existing infrastructure, which is kind of annoying. I was hoping we would be able to do that. I guess for the moment, anything that is not, you know, highlighted and then is tagged with SSL overlap, we know clearly came from that. We'll sort of just, we'll figure it out as we go along here. So let's go on our last 2 certificates. So this one has a lot of IPs compared to the other ones that we just saw. Yeah, a lot more data here. So let's make sure we add them in. So at the very least, what we are capturing is the new infrastructure that's associated with the SSL certificate. Let's do our final one here. Okay, another example of at least more IP addresses showing up. Add those in. Now I was hoping that we would get the opportunity to have these SSL tags persist or kind of merge together, because I wanted to see cases where IP addresses are being recycled on two different satellite providers. So it's not the end of the world, but I was really hoping to be able to capture that. So, okay, so we've got 62, we started around like 205, and we got 60 some more. So a lot more IP addresses showing up here for us to start going through and like interrogating a bit more. What I'm interested in is all SSL overlap IP addresses, keeping in mind this is not completely covering every single thing. I got 61 of them. I want to go through and show 100. I'm going to mark these all as suspicious. So in some cases we know that stage 1 was, the stage 1 IP addresses were also hosting these certs as well, so they're not going to show up with this tag. But these are all good avenues for me to go and explore. Before I do that, so we got our SSL certificates taken care of. I think at this point, from an analyst perspective, what I would do is I'd take a break and I'd start collecting a little bit of my thoughts here. There's a lot more infrastructure that I can go pivot off of. Before I do that, I think it makes sense to actually go and look at the web application. So we're going to take a quick break. We'll come back and we'll look at the web application that was on those 5 domains, and we'll try to identify anything of interest there, and we'll feed that information back if there is, and then we'll start going through the stage 2 overlap, or the stage 2 pivots, where we start looking at all the other outside infrastructure that we identified and find and enrich that information as well. Okay, so when we were doing our investigation of the domains, one of the things that we came across was some web application information running on a couple of the dynamic DNS providers that we found. So these were the results right here. So these domains were associated with our stage 1 infrastructure that was initially reported on, and we had all of the same web app looking information. So I'm just going to select one of these, and we're going to go run a pivot on top of that in order to understand and investigate this information a little bit more. So in looking at this data, I'm guessing that these guys have copied the cars.com web page, because I'm seeing a lot of cars.com information show up. Now, if I pivot on, let's say, this Facebook ID, I would expect cars.com properties to show up. I may expect people who are advertising on behalf of cars.com to show up as well. So if I'm looking to make an analytical pivot around the Facebook one, we'll look at the results in a moment, but what sticks out to me as being highly unique to a web property would be something like this Optimizely ID. So Optimizely is a service that allows you to do A/B testing within the web page itself through some JavaScript snippet. And what we're seeing here with this ID is that it's a unique identifier that was generated for the cars.com web property, or what we believe is a cars.com web property. So in theory, in terms of reuse, we should not really see the Optimizely ID leveraged a lot by someone else who's maybe sharing advertisements for cars.com or sharing a cars.com post. So I'm going to pivot on that one as well. So we can see here that the Facebook ID, we have a number of different domains, and you know, if you've been paying attention or you've been following along, a lot of these results seem to make sense. Cars.com, Facebook.com, investors.cars.com, and then we start to see some interesting things pop out here. GreatEplan.ocry, Beauty-Expert, RobotechLFlink.com, Wikibah, Public VM, ZZUX, LinkPC, Public VM, Too Wacky. If you're looking at this, all of a sudden you're realizing, wow, this cars.com is actually showing up on a number of different dynamic DNS dynamic DNS domains that look and appear very similar to what we observed with the stage 1 infrastructure identified by Kaspersky as being associated back to the Turla group. Interesting. Now, I don't want to close these out, but I do want to switch over to the optimized lead ID. So in this case, we have 91 results. And again, a lot of the same situation showing up here. Let's go through and actually request for the full 100 results just to be shown on the same web page here. And I think what we're going to notice is some interesting patterns. If we go all the way back down, 2012, we got SIY, cars.com, loose.biz, Suge.biz. You know, these sort of stick out to me as interesting. I don't know what that means. HTML-5, pickuptruck.com. So these, up to a certain point, you know, I'm looking at right around all below here, look like they are probably some sort of auto theme. Like, despite them looking weird, I would probably probe into some of these. But then starting in 2017, we start to see, or I'm sorry, starting in like October 2017, we see a dynamic DNS provider. We get this meller.ml. So ML is weird to me because it's a TLD that doesn't really get registered often. So we got this Cyron, which is dynamic DNS. And then we have a number of other TLDs right around the same period as 2018 that starts to show up here. And this seems to match a lot of what we see with these malicious actors. So the use of, in fact, here's your overlap on some of them as well. So supernews.instanthq, as one would expect, I believe that was part of our initial search back in our project. It was. So a lot more interesting ones showing up here beyond the ones that we've already identified. So we identified 5 of them, and I'm seeing way more than 5 showing up here. So what I would probably do at this point is go through and meticulously, I would select everything because we know which ones are probably related to cars.com. Anything that's cars.com, we just want to exclude that out. Or this pickup trucks. Let's get rid of that. Let's get rid of auto finder. Let's see, let's get rid of the IP addresses just because I'm not sure how useful they would be. Or auto finder. I don't know what this one is, the RT truck, but this is where we want to put in just a little bit more work to understand if this infrastructure is related. Let's make sure we got it all. Get rid of those IPs. We'll go and handle the IP addresses separate. So what's interesting here is that looking at the time period, sometime in 2018, this year, these guys decided to potentially copy the cars.com webpage and use that as a parking page for a lot of their infrastructure. Now, I don't know if this is them, but I do know that we have 5 domains that are dynamic DNS, and what I'm seeing here is a lot more dynamic DNS show up. So it certainly sticks out as a little bit strange to me. Okay, so we got, I think, most of the stuff weeded out here. We can run some searches on the other ones. So what is this loose.biz? I want to go to it. So let's say google.com. It's going to end up there. Let's see what we got. Let's do some quick research and homework on these. So this one's sticking out. Oops. I don't know much about this one. Let's go through and run a quick pivot on it. Be interesting if this was a tactic that these guys were using back in 2013. But it seems a little weird. Okay. Maybe what we're looking at here is an optimized lead ID that was potentially recycled, which could be of interest. Who knows? Like, that doesn't look. This infrastructure doesn't really scream out as anything malicious here. It's got an extended period of time of been around. Who is information's privacy protected, unfortunately, so I can't see much. I'm not going to add this. So I'm going to get rid of that. I am interested in this one right here. I wonder if this is some sort of like content provider for this. RTRK, BMW Starts Corporation, TT Tech. Oh, that's a different domain, so it could be a typo squad. So we search for rtrk.com, and what's coming up as a legitimate one is this RT-RK. Does the real one actually exist? So this actually could be a BMW Starts Corporation with TT Tech Auto and RT Tech Automotive. Online marketing agency, call tracking. We don't care. Smells legit. What about this org? TLD that sort of sticks out. Old Colony Civil War Roundtable. All right. We at least know like there's some value, like there's some information there. I don't know what it is. This matches the same pattern, so it's probably not that worthwhile. Let's wonder if this matches the same pattern we saw with the loose.biz. A lot of data, no resolution. Yep. Components here. It's probably just related to something that's old, especially since that time frame is so early. What about this HTML5? Websites. Looks like a legitimate hosting. Oh, this looks like it could be a dynamic DNS provider as well, or something very similar in nature. So 2016, we're seeing everything in earnest show up really in 2017, 2018. So I'm going to venture to say this may not actually be related. Let's live a little, see what happens. Okay, looks like we might be staring at a parking page here. I'm going to get rid of that. This one sticks out. Okay, not seeing a lot. Let's see what shows up. Same thing with this guy. So running a search, US networks, software, and Cyrus1. Who is information points me to Spider World at yahoo.uk. We do have some SSL certificates. Let's Encrypt, so somebody's actually went and put an SSL cert on here. Components wise and trackers. We got our Optimizely ID and our Facebook one. And this appears to be grabbing things from cars.com. Oh, no, cars.com was seen reaching out to this. So that gives me a better indication that maybe this is spam. Looking at the domains that are also associated with this, certainly is a little weird. But the fact that cars.com was reaching out to the website, as indicated by our host pair here, www.cars.com, had a script source reference over to this Misafic Pro. I don't know exactly what the purpose of this is, but you know, if we really wanted to, Google safe browser check, we can actually go run a search for this and just see. See if this thing's been blacklisted. If not, maybe it makes sense to kind of go and visit it. What the diagnostics here? Okay, let's check. No unsafe content found. Let's see what's up. Oh, that wasn't even the right one. No available data. Okay. Given that cars.com was referencing it, I'm going to skip it. Final one here we're going to look at is this one, cars.fo3 basic. So this is reaching out to cars.com, reaching out to Facebook. No certs, a lot of subdomains, so doesn't give me a good indication of whether or not this, oh, afraid.org. We see that on the name servers. So this looks like it could be legitimate. So maybe it is 2016 that these guys were kind of making their rounds throughout, and that maybe this one is of interest. And at that point, you know, pickup truck becomes all of a sudden pretty interesting. But legit. Okay. So the only one that sort of, this one's still weird to me, but the fact that cars.com was kind of reaching out to it is just, that would mean that they have compromised cars.com. So I think for the moment, we'll look with all of these. We're going to add these in. We're going to go first, modifying these other 60 domains. We're going to mark them as suspicious, and we're going to say optimizely overlap. And yeah, I think it's good. So we're going to submit all those to get tagged. Oh my God, and it just unselected them. Let's see if we can refresh this. Damn it. Oh, that moment when things break. So we'll go back through very quickly and do this again. And to be safe this time, I'll just download the results. So I'm going to select all, get rid of the cars.com stuff. Get rid of our IPs. Almost there. Okay, and now what I'm going to do is copy those off, load them into a little side list so I don't actually waste my time again. Grab all those, bring them over to our project. So what I want to do here is add those artifacts in as domains, and I want to say optimizely overlap. Get all those added. I want to make sure that we're capturing this too, since it ended up being very useful for us. So we can get rid of this. We did see a lot more here, so I'm going to request the 500 from the Facebook ID. So we got that added. Those are all pumped in. 318 indicators now. Okay, so I'm curious, like, how many more items showed up here that we need to look at. Oh, a lot more information. So we can see some of those MLs, 2 wacky E-towns. I'm just curious to spot check some of these. Let's do a show. Say 500. So we had 56 websites before. Some of them are already marked as malicious, meaning that we've seen them already. So what I want to do here is mark these actually as suspicious all. Okay, so this is starting to get pretty complicated. We got satellite infrastructure, we got SSL certificates being leveraged, we have IP addresses that are seen hosting the same SSL certificates. In the highest case, it looked like 30 some of them. We have a cars.com web application that appears to be maybe copied and then hosted on some of these dynamic DNS domains where they didn't change out the optimizely ID. We have some more overlap, it looks like, when some of this Facebook ID overlap as well, to where like this is probably worth going down and looking at all 200 of these. So let's quickly go through there. At this point, like, we haven't even gone through and touched the PDNS overlap from an IP address perspective, or the SSL overlap for that matter. So there's a lot of information still here. Now, to be fair to what's going on with the investigation to some extent, I can say a couple of things benefit us when doing the investigation at the time of publishing. And one of those is that at the time of reporting from Kaspersky, there was not a mention of the SSL certificate. There wasn't much known about that. As we started to pivot around and look at the data, we identified a lot of the SSL certificates that we went through today. And in some cases, in particular, there were 2 SSL certificates that we noted that appeared to be leveraged by the actors themselves. And one of them was this F4158 certificate, and the other was this FCC AE certificate. So the F41 certificate was used around the 2013 time period up until the day that Kaspersky had reported on content. Shortly thereafter, we had actually done an investigation and identified this. We blogged about it, and it was that blog itself, as part of open source and contributing back, that the actors then made that change, and they decided to start using that FCC AE certificate, again, self-signed. And the reason why we were able to find that is because the address that they used overlapped with the previous certificate that we had seen. So we were able to correlate that infrastructure and continue monitoring that as time went by. And now what we're looking at in terms of the web application is it appears as if these actors have taken the cars.com web page and decided to use that as a decoy page on top of some of their domains. And so we see that as indicated by pivoting on things like the Facebook ID and on the Optimizely ID. So there's a lot of opportunity here for us to go through and start analyzing this more. And what I want to do right now is just try and take everything that I can from my analyst background and see if I can identify all of the dynamic DNS providers or things that sort of stick out to me as probably being related to these guys. And get that from the cars.com Facebook ID, because it appears that there's more domains here than what we saw on the Optimizely ID. And we want to make sure we're trying to capture as many as possible because they all become valid leads. So let's see if we can identify a time period. These stick out. So this 2017, let's start moving up the chain. Chicken killer. So what we're seeing potentially here with the use of these weird TLDs is a changing tactics. Maybe the malicious actors are deciding to go register these domains, or maybe there's some sort of free domain provider that offers a bit more obscure TLDs here. So it's an absolute pain to kind of go through this process, but it's important for us to at least try to cover as much as we can. And you can see here, there's just a lot of information. All these are dying. And all of them seemingly have like just random looking subdomains. There's not a lot of value that we're getting out of them. All right, Wikaba, Twilight Paradox, Strangled. Man, so many. So what's strange to me is, in thinking, why would an actor do this? Why would someone who is running an operation decide to download the cars.com webpage and then basically correlate all of their infrastructure using that data. You know, I know they probably don't realize that, but that's a strange thing to do. Why would you put cars.com on all of your different domains? Okay, so here's the list that I have. Without making it unique, it's about 90 domains. I imagine that a lot of this will already be in our project. Overlap. Let's go and add this in. So we're at 319 now, or 318 now. Let's see how much this is gonna make our project grow in terms of data here. 354. So what delta is that? 354 minus 318. About 36 new domains that we didn't have now are associated here. So we want to make sure that we're showing all of them, and that we then select the page. We're going to modify it, mark them as suspicious. So 91 new domains that are dynamic DNS. They seem to follow a similar pattern, and they're all correlated in a weird way through this Optimizely ID, which appears to be associated with cars.com. Let's, out of curiosity, look and Google Safe Browsing check again and identify here if these are even marked as malicious by Google. Is this something that in theory we could visit or run a search? So I'm going to go actually to urlscan.io. And this is a helpful service just for seeing what's on the web page. And I want to go here and identify, or rather search for, I don't necessarily need to crawl it, though I don't mind. Well, it doesn't look like there is one, so we'll let that go. We'll do a public scan, and we'll eventually just come back to this information. But let's see here. Does this dixito.ml actually show up with the cars.com webpage? And it does appear. So we're getting a preview there. We'll let that load in the background. Google hasn't marked the page as malicious. They're typically pretty quick at doing so. So maybe what we got here is some staging infrastructure that is being leveraged on behalf of the users. But in any case, like, we want to make sure that we add in this Facebook ID and get that tracked. We got a lot of information that we could go look at. I mean, a lot. All of these things are different dynamic DNS domains that we could start to kind of go into. In terms of next steps here, you know, we went again from 50 to now 350 indicators of compromise. I think what I would probably do is another pivot session on the IP addresses, in particular looking for the PDNS overlap. So these are cases where we identified these IPs, and now those IPs are going to have domains as well. So now, since we've already went through and categorized all of the domains from stage 1 and stage 2 and related to this tracker, I think it makes sense for us to kind of go through the IP addresses and start looking to see if there's any new domains that are associated with the IP address from PassiveDNS. Before that, let's just see if our results loaded here. They did. So very cool. It is, in fact, a screenshot of cars.com's website. And if we go to cars.com, we can kind of make some quick eyeball comparisons of what we got here. Looks kind of the same. The search by make is a little bit different. They have something new in there. And in this case, looks like, you know, they just copied some of it, but not all of the pages, you know, refreshing as we would expect. So it looks like cars.com in production has changed a little bit. And if we go here and we just look at, oh, if we look at the DOM, curious, where's that Optimizely ID? Oh, I don't want that. I want the content. Oh, looks like they break it out differently. So maybe it is the DOM. Let's see if we can load this up and identify the information found within the page itself. There we go. So Optimizely, there we go. So it appears that Optimizely is referenced up top in some sort of configuration profile. And we can see here that Optimizely true, maybe Boolean value indicating whether or not to turn it on. And we can see that Optimizely, there's our script source. that shows the under index files, there's this ID, and that's the ID that we pivoted on. Interesting enough, let's go to cars.com today and see if we can get the same value. Or have they changed the website? So Optimizely is back on, and the value looks the same. Yep, appears to be the same. So livecars.com webpage has the one that we observed on our potentially malicious page as well. Okay, so very interesting. At this point, what I want to do is, we got the Facebook ID added. We got a whole bunch of leads there. If we really want to be honest with ourselves, I would probably go back and meticulously go through each one of those Facebook ones to ensure that we have everything accounted for. But for the sake of time and just demonstration, I'm going to start going through some of these IP addresses and see if we can find even more domains. So these are our initial passive DNS queries. Let's find if there's anything new here. And again, what's nice about the process that took place here is that we know that these, oh, you know what? These are the ones that we've already done. My apologies. We've already did the PDNS overlap ones. The ones that we want are the SSL overlap ones. So my apologies. So in the previous example, for the domains, we looked at the IP, we put those in. Actually, I take that back. Too much analysis will do this to you. So we do want the PDNS overlap because there was new things that we added into the project that were not related to our original stage 1 information. So let's kind of just quickly go through and spot check some of these and see if we have all the domains accounted for. And I'm very glad that I just did that and found myself correcting myself, because right away we have some interesting information here. So a sites, bbsindex.com and history.zapto.com, Sweden history. So right away, I pivot on this passive DNS information, and I have a couple of new domains here that are suspicious, and these are also stage, I don't want to call them stage 2 because it implies a command and control. These are secondary. We'll just call it secondary. Secondary in the sense that we started off with with our IP addresses and our domains. That's stage 1, our not stage 1, but our first order. This is second order. So in fact, what we're going to do is just call it second order. So as we get further out from our original starting points, it's kind of like the friends of friends of friends situation. We want to maintain that order only because the further you get out, the less likely something is to be related, or it has to have a stronger pattern. So we want to make sure that we got those in and that we add them to our project. We have an SSL certificate here. We've already went and handled this. So not important to dwell. We made sure that we tagged these as suspicious and then added them into our project. So let's go through and just one by one grab these IP address information and see what other domains we can find here. Specifically, any ones related to dynamic DNS. So we have, see this, I mean, this is a lot of infrastructure. So you can see here what I've loaded up, 29 results. And look at this. We have malicious ones that are tagged. We have malicious ones that are tagged as stage 1. And we have suspicious ones that are tagged with Optimizely overlap. So all of these other white ones, or ones without a green tag, are something that we have not associated to our project whatsoever. Which is crazy. There is an unreal amount of infrastructure associated with these guys. Now, when it comes to dynamic DNS, they're not offering you IP addresses to put your hosting on. So what we're seeing here is the actors willingly use certain IP addresses, and in fact could be all associated back to these same Turla actors. So what I want to do is then go put these as suspicious and put second order. Get that saved, add to our project, and we want to keep going down. So now if you're thinking to yourself, okay, we just found, 27 new domains Does that mean that I have to go to every single 27 second order domain and then look at the passive DNS on top of that? Unfortunately, the answer is yes. Now, we may not necessarily do that in this investigation simply because it's going to take too long, but that's absolutely what you would want to do in this case, because if these have new IP addresses, those might have dynamic DNS on them as well. And so what we're starting to enter here is a territory where I may pivot over to a link analysis tool like Maltego in order to visualize this information, because there's a lot of overlap and sprawl when it comes to this infrastructure. So we were on 210. Let's keep going down the line here. So no new data. We can kind of keep going on. New stuff. And it looks to be like dynamic. So I mean, it's just incredible like what you're able to find with some of these data sets. Now, I don't want to get too excited and say that these are all related to the actors, but if I was defending my network and I was concerned about Turla potentially targeting me, by all means, these would be all blocked on my network. Or at the very least, I'd be putting in some sort of silent signature in order to alert me to cases where we identified this information showing up. So another thing to point out here that I find to be interesting is that we're on an IP address, but our crawler is then associated that cars.com web application to this information as well. So this IP has data related to cars.com, and that's because when our crawlers went through, they either crawled the raw IP address or they crawled one of the web applications, and at the time it was resolving to this 154.65.51.122 address, and that's why we would see the correlation between the web app data showing up here. So 122, we had a couple new domains there. Let's keep going. And we're getting less and less information, but still some stuff here that's not, that is unique. Second order. We do have this one too. Make sure we get these in. We'll add those to our project. Okay, we have that information added. This is a good example, actually. I'm glad I stopped on this IP address. So this IP address has our passive DNS overlap. It has our certificate overlap. I mentioned previously that we had this 2013 F41 SSL certificate that was part of the original malicious actors when we had identified it. And then they later switched over to this FCC certificate later on. And what's nice to see here is that we have second order domains, we have stage 1 domains, we have 2 SSL certificates that kind of help us overlap the old infrastructure with a new one. And that's really sort of how these investigations work, and we're able to identify the malicious actors and their content for cases like this particular IP, where it sort of brings together all of the different information. It allows us to sort of start making an educated decision around what these actors might be doing. Okay, so let's keep going down the list here. That was 152, we're now on 207. And for the first time, we have nothing. So we'll keep going, 207, let's go to 110. So we have a couple items here that are just marked as malicious, but they're missing the suspicious second order, is what I want to call it. And the only reason that that might actually be taking place here is just because my account is part of an organization that has previously probably marked these as being malicious, and so that's the reason why that would show up. So that was 110. Let's keep going. Okay, got some stage 1, got our web app, got some stuff we haven't seen before, platforms 3D, suspicious second order. And we got 2 certs here, and these certificates, same sort of situation. So another 169 address, this intersat being leveraged for both certificates and sharing some stage 1 domains, or stage 1 domains, and then the reuse of them later on to actually host our web app as well. Okay, so that was 246. Look at 121 here. So again, this is just the tedious portion of doing the analysis work, is waiting for things to load and going through and trying to keep a track of what it is that you've seen before. This is an interesting example. So a lot of cases where the, okay, so we got a couple of dynamic DNS at the bottom, but this looks like there's some, yeah, I'm not quite sure what to make of this one. What I'm going to do is I'm going to pause for the moment. Okay. Apparently I was recording so much that it was actually just locking up my system. So we got a couple of things here. We want to definitely see more information. Curious, you know, some of these other results. So I can at least see that starting around 2013, it looks like this no IP Zapto zero design started showing up. There's a lot of information here. I'd be willing to sort of skip this one just because there's too much on Amazon. This could be a sinkhole. I'm gonna skip it for now. So it was that 174. Let's go through and look at this 181. No resolutions. Oh man. Okay. So another Wikibah. There's our stage 1 information again. Let's get that marked. Save, add to project. What provider do we have here? 213, so this is a DigitalOcean. This could be another case error. Yeah, these might be sinkholed or something else might be going on. You know, I think it's worth pointing out here, sinkholes, you know, if this is what it ends up being, could be valuable just to look at, because if the security researchers or whoever it is, oh, I can actually see up top, it's marked as a sinkhole. So whoever owns this sinkhole, these could be good leads to explore as well. They've already gone through and gotten the order to essentially take ownership of the domain, so that suggests that they are malicious, and we might want to actually spend some time on that. But it could be a number of different threat actors, so I want to move past those and kind of continue going down the path here of like the more unique providers, or the less popular ones. So 196. So we got almost all of these taken care of, except for this job, money, home biz. Add that one in, add it to our project. All right, got some new stuff here. Tiger story. Sea fish. So it's really not clear what the naming convention is with this. Like, this is a very strange usage of dynamic DNS and having this information all over. If we pay attention to time periods, though, it's a lot of 2016 infrastructure that we're seeing here, with some tailing into 2017 and a little bit into this year of 2018. So to me, what it suggests is that after the infrastructure and methodologies were made public, we knew that they continued to use SSL certificates. We later saw that that process was changed and adapted. We're not certain if they continue to use that, but we lost visibility. But it really looks like they continue to go through and keep using these dynamic DNS domains to potentially conduct some of their operations. And I bet that if we look at some of the content within the dynamic DNS domains, while some of them may look completely random, I bet some of them are also related to who they're going after or their victims or something along those lines. So this one, level 3 communications, I'm going to skip it. There's frankly too much information there. I remember when we added both of these items originally that we can see here that was added from resolutions. Before. The only reason I added this was because the use of dynamic DNS, there's frankly too much stuff there for me to start going through, and they could be sinkholes as well, so I don't want to spend too much time on those and investigating. So let's kind of keep going on. We're at that 156 now, so we're nearing the end of the second order. We only have one that has just not been tagged appropriately, so we're going to mark it second order. Submit that, save it, add it to our project. So it's our 156. No information there. Already got that accounted for. Host pairs showing up. So this is our so it looks like it might be related to that cars.com stuff before, so I'm going to keep on going. 239. All right, got some new stuff here. Not a lot, but every little indicator counts. Those saved. Add those in, and this was running the cars.com web application as well. So we got those added. That was 239. I don't know net. Looks weird. I'll take it anyway. Nothing there. Let's kind of get all the way to the end here. Load the last results. Nothing. All right, last two IP addresses. Still got some new stuff showing up here. So, I mean, this goes to show why it's worth tracking this down even more. So I'm gonna grab these guys. Yeah, I mean, there's a lot here. And what's important to note is that we're not really going through and investigating, the hashes or other details that may be associated with this infrastructure, but by all means, this is something where we might want to start running Google searches or PassiveTotal searches for all of this infrastructure that we've identified to identify any malicious samples or malware that has reference to these. Because if we find malware that has reference to it, then we can start cross-checking it to identify if it's related to the tool set that the Turla actors use. And if that ends up being the case, then we have a strong correlation that these second-order connections that are leveraging a shared third-party dynamic DNS provider could be of interest to us. So we've added those in. Our final IP address, if some of you noticed right away, a lot of different hosting infrastructure showing up on this thing, or a lot of different domains showing up every single day. Doesn't necessarily mean that it's a sinkhole, but in this particular case, someone has been nice enough to tag this as a sinkhole, so we don't have to go and analyze it. So we got a couple sinkholes that showed up there, and just when I thought we were done, I just ignored that second page, so it looks like we're going to keep on going. So we'll rip through these really quick, and then we'll sort of review what it is that we have. So, couple of these all unmarked. Make sure we're grabbing those. I don't know about this, that UCOM, I don't trust it. Serve Counter-Strike. Okay, suspicious, second order. Now, if you've made it this far and you're still watching this video, I gotta commend you on really wanting to pick up the analyst tradecraft and try to figure out how to spot nation state actors, or even just be able to apply this data. As you can see, me going through this and spending hours is something that I enjoy when it's something that's brand new and I haven't seen before. When it's doing an investigation like this, it's the irony is not lost to me that these are some of the initial investigations that we really broke open, and none of this should be a surprise to me as we go through it. However, looking at some of the infrastructure, it's new and as of like present day. And so what I think is important here is to constantly go back and revisit these open source intelligence projects, simply because like an actor who's been burned in the public doesn't necessarily mean that they're gonna stop or change their techniques. So we got a couple examples here. I'm kind of suspect of these, especially the ForthNet one. The ATH ones look interesting though, but the time period certainly jumps back. So you can see here, like from the Kaspersky reporting, we were dealing with a timeline of early 2012. It looks like it goes back as far as 2011 according to some of our data. So I'm going to add these in anyway. It's good overlap with our stage 1 infrastructure. Oh man, looks like another good example of a lot of stuff that has not been accounted for yet. I almost missed that page, and had I did that, I wouldn't get all these great indicators, mentioning Adobe, EU News. I mean, these could be cases for, Newsweek. It's important that we go through and try to check under as many, rocks or data rocks as we can, just because we get things like this where all of these could have been used by the actors at some point in time. 25 new ones. Get those added. It's at 12. Oh, shoot. Just noticed something here. These IP addresses are at least marked as sinkholes. Now, for that example, I think we're okay. This one looks like it's probably okay too. Like they might be related. I'm going to go and add these in because the time periods overlap quite well, as does the dynamic DNS. But if I were actually doing a full investigation here and I wanted to kind of remain true to the actor, I would be a little bit hesitant about putting something that came in from a sinkhole, simply because it may be unrelated. In this case, I'm going to mark it and say second order. But the way that I know it's a sinkhole usually is that it will tell me up top, and I just simply wasn't paying attention in this case. So we'll add those things in just in case. But in the future, I probably wouldn't spend too much time looking at those sinkholes, because it could be that a security researcher has set up a sinkhole and they have multiple actor infrastructure funneling in. So when I go to add those to my project, it may complicate the project, or it may create connections that don't actually exist. So this one, this might even be a sinkhole as well. It's just not labeled. I'm seeing, 2,000 some domains here. I don't want to spend time on this one. We'll open up its little brother. But we can see here black shades, dark comment. Oh, there's another sinkhole. Don't even want to bother with it. So we'll keep going. There's our satellite IP. Okay, take a look at these results. So more useful information. Okay, and after this, I think we're going to call it. So clearly there's a number of different paths we could continue to go down. Even as I'm calling it, we can see here that there's still additional domains that we might want to look at. So I'm going to go through and refresh our Turla project here, and you can see that we have 508 artifacts. We started off with 50 from an intelligence report that was roughly 3 years ago. And we're not only seeing this, like the same patterns that were shown back then by these malicious actors, but we're seeing infrastructure that appears to be active as of today. And keeping in mind that we ran one of those domains that was connected to the cars.com infrastructure, which was connected to the satellite infrastructure, which was then correlated by the SSL certificates, that was still active as of today. And so I think it's important to note here is that even in just the short period of time that we've spent going through this open source information and really doing our investigation, there was a lot of data that we uncovered. And if I'm a defender, I'm able to leverage this to essentially block this information, potentially protect myself from the Turla actors. And even if I choose not to block it, I'm just an investigator, these are great leads for me to go off of. And what it tells me is, one, the Turla actors are probably not going to be deterred by public reporting. Two, that regardless, of whatever's reported about them, I could probably find them through some sort of operational mess up. Three, there's a number of patterns that they had exhibited. One, using SSL certificates. Two, using satellite infrastructure. Three, using dynamic DNS providers. All of those things help to kind of build up a profile for this actor and allows us to intelligently track them going forward. So hopefully this this module was helpful for you in identifying how to go through and conduct an investigation, starting with some open source intelligence and seeing how there was multiple different techniques that sort of brought us to really starting with 50 and ending with 500 some indicators. And I would bet that if we continue to go down this route, we could easily end up with close to 1,000 indicators that are associated to these Turla actors that could be blocked or continue to be monitored. So for those who made it to the end, I got to give you credit here. This is a lot of information to take in. If you have any questions, feel free to reach out to us and we're happy to answer them. Thank you.